Hello everyone, I am Dr.VRAO-PHYSICAL. Today I am here with a new concept, that is electrochemical series. In the last lectures of electrochemistry, we learnt determination of electrode potential, and we came to know that it is impossible to determine the single electrode potential. I repeat, it is impossible to determine the single electrode potential. If we want to determine the electrode potential of any electrode, that should be combined with a standard hydrogen electrode whose potential is 0, and construct a cell and measure the EMF of this cell, then the EMF of this cell is equal to potential of that electrode, right. By measuring the potentials of various electrodes versus a standard hydrogen electrode, a series of potentials of electrodes has been established, right. And when the electrode in contact with its ions are arranged on the basis of their standard reduction potentials or standard oxidation potentials, the resulting series is called electrochemical series, right. Here is the electrochemical series. You can find the electrochemical series on this board, and but I do not present all the electrode potentials or total electrochemical series. I confine it to certain metals only to understand, to explain the concept, right. So, when electrodes in contact with their ions are arranged based on their standard reduction potentials or standard oxidation potentials, the resulting series is called electrochemical series. But as per the international convention or as per IUPAC convention, the potentials of electrodes are tabulated for reduction half cell reactions, right. I repeat, as per IUPAC convention or by international convention, the potentials of electrodes are tabulated for standard reduction, tabulated for reduction half cell reactions. So, you can find that all these reactions are reduction half cell reactions, right, reduction half cell reactions. So, this is electrochemical series. So, here is the top of the electrochemical series is the metal at the top of the electrochemical series is lithium, and the non-metal that is at the bottom of the electrochemical series is fluorine, right. You please observe this electrochemical series, right. So, why the question is why we are writing the electrochemical series as in reduction half cell reactions, because as per IUPAC convention, the potentials of electrodes, right, you please keep your mind on my words. The potential of electrodes are arranged on the basis of their standard reduction potentials, right. So, the potentials of the electrodes are tabulated, for reduction half cell reactions. Why we are giving that electrochemical series in reduction half cell reactions? Because for indicating the tendencies of metals to behave as cathodes or anodes against standard hydrogen electrode, right, to indicate the electrodes, to indicate the tendency of electrodes to behave as cathode or anode against standard hydrogen electrode. We are presenting the electrochemical series or we tabulated the electrochemical series for reduction half cell reactions. So, here is the electrochemical series. You can find the electrochemical series. I am not providing, I could not provide the total electrochemical series. To understand or to explain the concept, I am confined to certain metals only. So, here is the lithium is top on the electrochemical series, and fluorine, the non-metal fluorine, is at the bottom of the electrochemical series. Let us learn the characteristics of electrochemical series. Okay, you should know because it is very important concept. It is very important concept. Unless you understand this concept, you may feel ambiguity in solving the problems, right. So, let us learn about the characteristics of electrochemical series, right. What are that? Characteristics of electrochemical series. Characteristics of electrochemical series, right. If you find this electrochemical series with your naked eye, that is when you see this electrochemical series, you can find the negative potential, you can find the negative value for reduction potential for lithium, right. You can find the negative reduction potential for lithium. And as we go down, the negative reduction potentials are becoming as positive reduction potentials, right. You should observe that values. So, the electrochemical series starts with negative reduction potential, negative standard reduction potential. Here now one words we can call it as SRPs, standard reduction potentials. So, electrochemical series starts with negative SRP value, that is negative standard reduction potential, right. As we are going down, that negative standard reduction positive value or negative standard reduction potentials are becomes as positive potentials. And if you find this non-metal, that is fluorine, you can find the positive standard reduction potential value. So, plus 2.87, but for lithium that is minus 3.04. What is this negative standard reduction potential indicates and positive reduction potential indicates, right. You please keep your mind in my words, on my words, right. So, a negative sign of standard reduction potential indicates that when that metal combined with the standard hydrogen electrode, then that metal acts as anode, right. You got the point? I repeat, the negative sign of standard reduction potential indicates that when this metal is combined with the standard hydrogen electrode, this metal acts as anode and oxidation takes place at this electrode. For example, if you take zinc metal, if you take zinc electrode, if you the potential of the zinc electrode is minus 0.76 volts, okay, minus 0.76 volts. So, what is that negative standard reduction potential indicates? That means if this zinc electrode combines with the standard hydrogen electrode, electrode, that zinc electrode behaves as, or that zinc electrode acts as anode. So, the negative sign of standard reduction potential indicates that if that metal is combined with the standard hydrogen electrode, then that metal acts as anode, right? And what is the positive standard reduction potential indicates? The positive sign of standard reduction potential indicates that, I repeat, the positive sign of standard reduction potential indicates that if that metal is combined with the standard hydrogen electrode, then that metal acts as cathode, and that metal acts as cathode. Let me give one example for this. For example, if you take a copper electrode, the reduction potential, the standard reduction potential of copper electrode is 0.34 volts. That means what that positive value indicates? That means if the copper electrode is combined with a standard hydrogen electrode, and if you construct the cell with both these electrodes, the copper electrode acts as cathode. Right? So, what you kept in your mind is that negative value of standard reduction potential indicates that is negative sign of standard reduction potential as per the electrochemical series is concerned. That negative sign of SRP value indicates that metal behaves as anode when it is combined with standard hydrogen electrode, right? And the positive sign indicates that if that metal is combined with standard hydrogen electrode, that acts as a cathode, right? So, okay, you please observe this electrochemical series, right? Here that is the one characteristic. Already we learnt one characteristic of electrochemical series, and the second characteristic of electrochemical series is the substances. You already, I hope you are all understand, or you are all observe this standard hydrogen electrode reduction potential value. Already we know that the SRP of hydrogen electrode is set to be 0. Okay, that's why we use it as a reference electrode. Okay, so this electrochemical series, you can find the two parts in the electrochemical series. The metals which are above hydrogen electrode and the metals which are below to hydrogen electrode. So, the metals which are above hydrogen are negative SRP values, right? And the metals or non-metals or the substances, it is better to call it as substances. The substances which are above the hydrogen having the negative SRP values, right? And the substances below the hydrogen electrode having the positive SRP values, right? So, from this we can understand one point, that is one characteristic, that is the substances which are strong reducing agents, the substances which behaves as a stronger reducing agents. Okay, I repeat, you please keep your mind on my word. Okay, the substances which are stronger reducing agents than hydrogen are placed above the hydrogen in the electrochemical series, and those are having negative SRP values. right. So, the substances which are having negative SRP values are acts as or behaves as stronger reducing agents, right, and the substances which are behaves as or which acts as strong oxidizing agents than hydrogen are placed below the hydrogen in the electrochemical series. That means the substances which are having positive SRP values or behaves as strong oxidizing agents, right. So, from top to bottom, okay, from top to bottom, the metals which are at the top of the electrochemical series are the metals or the substances which are having negative sign of SRP that acts as strong reducing agents, that is the reducing capacity decreases, okay. So, oxidizing nature, the reducing nature of the metals in the electrochemical series decreases from top to bottom, and already we know that the metals and if you go from bottom to top, oxidizing power increases, right. So, what you kept in your mind is that the substances which behaves as strong reducing agents than hydrogen are placed above the hydrogen in the electrochemical series, and the substances which acts as strong oxidizing agents are placed below the hydrogen in the electrochemical series, right. So, that is the another characteristic, and the third characteristic is the metals which are on the top, or the metals which are having negative SRP values are ready to lose electrons, right, are easily lost electrons, okay. The substances are the metals which are at the top of the electrochemical series are easily lose the electrons, or they lose electrons readily. That tendency is called that type of activity, and that metals are called as active metals. That is active metals. What is meant by active metals? The metals which are lose electrons readily, or the metals which are lose electrons readily are called as active metals. So, metals like lithium, alkali and alkaline earth metals are active metals, because all those metals, all those elements, alkali and alkaline earth metals are readily lost electrons. That is why all that metals are called as active metals, right. And more simply we can say that the metals which are having negative SRP values are readily lose electrons and are called active metals. Of course, and one more thing is that the non-metals which are at bottom of the electrochemical series, for example, if you take fluorine, okay, only the fluorine, I give you only one non-metal here, okay. So, fluorine, this is the metal, the non-metal which is at the bottom of the electrochemical series, okay, have a tendency to gain electrons, okay. The non-metals which are at bottom of the electrochemical series are having the tendency to gain electrons. Those are called active non-metals. Because that non-metals are readily accepting electrons. That is why we call it as active non-metals. Okay. So, from top to bottom activity of metals, decreases, right. So, that is the another characteristic. So, that is the another characteristic, and one more important point is that the metal with the least reduction potential, that is including the negative value. So, the metal with the least reduction potential behaves as a strong reducing agent. Okay, I repeat, the metal with the least reduction potential behaves as a strong reducing agent. The metal with the highest reduction potential behaves as a strong oxidizing agent. For example, lithium. If you take lithium as an example, lithium which is having least reduction potential value, that is minus 3.04 volts, okay, which is the only metal which is having least reduction potential. That is why lithium can act as a strong reducing agent. Okay, and the metal with the high reduction potential value acts as strong oxidizing agent. So, the only metal that is having positive highest reduction potential value, the non-metal having high standard reduction potential value, that is 2.87, that acts as strong oxidizing agent. No other element can oxidize fluorine, right. So, these are the characteristics of electrochemical series. Okay. So, what you should interpret from the electrochemical series is negative sign indicates that electrode acts as anode, positive sign indicates that electrode acts as cathode. Okay. The metal with low SRP value is called acts as a strong reducing agent. The metal with this positive highest SRP value can act as a strong oxidizing agent. Okay. Let us go for applications of electrochemical series. Okay. Let us learn about applications of electrochemical series. Of course, n number of applications for electrochemical series, but I shall confine it to 1 or 3 applications due to time constraints in this channel or in the video, right. So, first application is reactivity of metals. We can explain the reactivity of metals or activity of metals by using this electroactivity of metals. We can explain the reactivity of metals or activity of metals, right. So, activity of a metal depends on the tendency to lose electrons. Okay. Activity of a metal depends on tendency to lose electrons readily, The metal which is having which have a tendency to lose electrons readily, that is called active metal. So, and we can say that the electrode with the negative SRP value is readily, already we learned that the metal which is having negative SRP value is lost its electrons readily. So, the metal which lost its electrons readily can act as its reactivity, that is called activity. And if you go from top to bottom, the activity of metals decreases, because the tendency to lose electrons, decreases from top to bottom, right. That is one application. And second one is electropositive character of metals, second application is electropositive character of metals. Okay. So, electropositive character of metal also depends on tendency to lose electrons. Okay, if the metal is ready to lose electrons, its positive character increases. Already we learned that we discussed that the metal with negative SRP value lost its electrons readily. That means it becomes it is readily acquiring the positive charge. Okay, if that metal lose its electrons, what the charge that metal have? Positive charge. So, electropositive character also decreases from top to bottom. Okay, we can remember the electropositive character of metals with a small mnemonic, that is this is very important, because why I am giving this mnemonic or why this mnemonic is very familiar, because based on this mnemonic we can solve the questions easily. That the mnemonic is PSBC magent L CHAP, CHAAP. So, electropositive character decreases from top to bottom. Okay, we can remember that electropositive character of metals by this mnemonic. What this mnemonic says? This is P stands for potassium. Potassium is more electropositive than S for sodium, right? B for barium, C for calcium, right? Okay, M for magnesium, A for aluminum, Z for zinc, I for iron, Fe, right? N for nickel, okay. T for tin, Sn, L for 1 minute, right, L for lead, right, and C for copper, H for mercury, A for Ag, first Ag comes, then after Au, and last finally is platinum. This is electropositive character order. Okay, so PSBC magent L CHAP, right. So, in between magent L and CHAP there is hydrogen is there, right. So, this is the order for electropositive character of metals. Another application is the metal with the least SRP, the metal with the least or negative SRP, or the metal with the least standard reduction potential can replaces the metal from its aqueous solution whose SRP is positive. Simply we can say that the metals on the top, the metals on the metal which is the metal is on the metal which is in the top can replaces the metal of an aqueous solution underneath. Okay, underneath metal in the underneath. That means simply we can say that the metal which is having least SRP value can replaces the metal, for example if you take zinc sulfate, for example zinc, and here we have a copper sulfate aqueous solution, and when these two are allowed to react, then zinc replaces copper from its aqueous solution, So that is one of the most important application of electrochemical series. But I am giving you one more important thing is that so which combination of these metals in the electrochemical series can give the cell with the highest EMF? I am asking you again, which combination of metals can give the cell with highest EMF? Usually when we construct this cell, we need two metals. One is anode and another one is cathode. So which combination of anode and cathode can give the cell with highest EMF? The half cells with the greatest difference in reduction potentials can give the cell with highest EMF. Okay, for example, if you take a lithium fluorine, the difference is 2.87. For example, to understand the statement 2.87 minus of minus 3.04. Okay, so this is 2.87 plus 3.04, that is which comes out to be 2.87 3.04 7 4 11 9 5.91. okay, so like that. Okay, this is the application. So for example zinc and copper, this is the Daniell cell. Best example is the Daniell cell 0.34. if you take difference of this 0.34 and minus 0.76, 0.34 minus of minus 0.76, that is 0.34 plus 0.76, that is 0, which comes out to be 1.10 volts. Okay, in this way we can construct these cells which are having a high EMF. Okay, I hope you all understand this electrochemical series. If you really like this video, you please extend your support by like, share, comment and subscribe. Thank you.